Systems of equations, here we go. Now, in this chapter, you're going to learn all about systems of equations. Probably more than you'll ever want to know, but that's what needs to be covered, so we're going to cover it, and we're going to make sure that you can master all these methods. Now, the first thing we're going to do is system of equation by graphing. So I got your graph set up for you right here, and all we have to do is remember how to graph lines. So hopefully we have everything in slope-intercept form, slope-intercept form. If not, that's going to be step 1. Solve each equation for y, if not done already. So first one is done for us already, so I'll use this as line 1. So we do have -3, 1, 2, and 3. So we have a y-intercept of -3. We're going to use a slope of 2, 1, 2, and run 1. Alright, what you want to do is be very, very careful because we want to try to be very exact in what we're doing so that when we graph both lines, we can try and find out where they cross because that's what we're after here. Okay, so we're going to graph one line, then graph the other line. So let me get, we'll call this line 2, so -1. And we're going to use 1 and 1 and 1 and 1. Now what you'll notice when I do this is I'm going to use a couple extra points so I can try and really line things up. But here's my second line. So we're going to graph one line, then the other line. And the last part is to identify the point that the lines intersect. So for this system of equations, I see that we're out at 2 and 1. So 2 for x and 1 for y. Pretty easy stuff. We're not doing anything new. We're combining a couple of the ideas that you have known and things we worked through in Chapter 5 as far as graphing lines. Okay, so the other thing we know right away is they are not parallel lines. They're not perpendicular lines. So we know they're going to cross at some point. So that leads us into what we're going to talk about. When we do a system of equations just like we did, there are 3 things that can happen. Alright, bottom line is, the 3 things that can happen are just like this. I have line 1 and line 2 just like we had. So the slope of line 1 is not equal to the slope of line 2. So we're talking about it's 2 lines that will intersect at one point. So here's our one point that they're going to intersect. If we had a grid on here, we could figure out the point. But if you see that the slopes are different, we're going to get one solution and one point of intersection. So one solution. Now, if you happen to notice that we have the slope of line 1 is equal to the slope of line 2, second part we'll notice is the y-intercept is not the same. So B1 is not equal to B2. We're talking about parallel lines, and what that means is there is no solution. So although we're talking about systems of equations by graphing, I want to show you the 3 things that can happen. So far, one solution, no solution. And here we have line 1 and line 2, and they lay right on top of each other. So the slopes are equal, and the y-intercepts are equal, which means we're talking about the same line. Now in a system, the point that they share is the solution. If they're the same line and they share all of the points, then it's all real numbers. Okay, or infinite solutions. Remember, we can use our double-stroked R. So these are the 3 things that can happen. Most often, it falls into we're going to find one solution. But we will have parallel lines, and we will have the same line from time to time to keep you on your toes. Alright, some real-life examples. Here we go. Travis and his band are planning to record their first CD. So this happens all the time. People create bands, they want to create a CD, they want to become famous, all those things happen. The initial startup cost is $1,500, and each CD costs $4 to produce. Not that anyone buys CDs anymore. They plan to sell their CDs for $10 each. How many CDs must the band sell before making a profit? Well, here we go. So cost of X CDs is Y. Is always going to refer to the equal sign. Cost per CD. What's going to cost them $4 to produce it, plus how much to start up? $1,500. That's exactly right. So here's our $1,500, and it's going to go up by 4. Alright, so we see this line going up. So this is how much it's going to cost them. Now the second thing going on here is the price per CD, which is $10 per CD. Well, if nobody buys any, they make nothing. So this is always, on this line is always their profit. So y equals 10x. Now we see that it intersects at 250 and 2,500. This is the break-even point. If they sell 250 CDs, okay, because number of CDs is on the x-axis, so it's the x value of the ordered pair, they will break even. That means they will have spent $2,500 and made $2,500. For every CD after that, how much are they going to make? Now they're going to sell it for $10, but it cost them $4. So their profit is going to be $6 per CD after profit is $6 per CD after 250 CDs sold. Okay, so there can be a lot of very interesting questions as to follow up with any of these problems. But that's a real life example. So let's get into the practice of actually graphing them and what I'm going to ask you to do with it. Alright, so again, we want y equals. Well, we got that. So we're going to go ahead and graph this one, -2. And we're going to be very careful to be very particular about our points. So slope of 3, 1, 2, 3, run 1. And we'll connect those 2 points. And often what I'll do is put some extra points on here. Make sure I extend it and it looks good. That looks good. Alright, second line we got. We have -6. Alright, and I have -1 for a slope. Now I can also work backwards. That way I can find the point of intersection before I even graph the second line. But I'm going to put a line on there anyway, so it looks nice and purty. Oh, I like when it looks purty right there. There it is. Alright, so the ordered pair is -1, and it goes the whole way down to -5. We're in the third quadrant, right? 1, 2, 3. So third quadrant, so I know they must both be negative. So -1, -5. And that's how we graph a system of equations. Alright, next one is still y equals and y equals. So we're giving you the gravy problems right now. Right? So we got +2. We're going to rise and run 1 and 1. Maybe I'll go backwards 1. I'm not sure where this thing's going to meet up. But a couple extra points won't hurt anything. Second line, here you are, -1. And we're going to go up 2 and over 1. Oh, up 2 and over 1. Up 2 and over 1. Alright. Let's see here. See, the nice thing when I put extra line points on there, I can make sure I line them all up. Here we go. So I have located my point of intersection right here. So if you want to go ahead and tell me what ordered pair that is. 1, 2, 3, so 3, and it goes up to 5. First quadrant, so both positive, so that's good stuff. Okay, so graphing 2 lines, find the point that they intersect. Alright, now the only thing we can do to make this more difficult is not give you y equals. But with all the practice you did in chapter 5, that's not a big deal. So for our first equation, it's all done, so let me do that one first. So -1, and we're going to rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. So now I can get a nice solid line on here. Second equation, we have a little bit of work to do. They want me to distribute, because then 3x minus 3, so -3, and we'll go 1, 2, 3, and 1. 1, 2, 3, and 1. Alright, so before I do anything else, I know this is the point of intersection. I'm going to work on trying to make this line as neat as I can. Make sure you're using a ruler for this. It'll help. Alright, so point of intersection, it looks like 2 for the x value and 3 for the y value. 2, 3. So again, the only way I can make this more difficult on you is to make you do extra work as far as setting it up so it's y equals. But you guys are smart enough. This is a no-brainer. Alright, now I can really challenge you. Throw some things out of the way here. We have, let's add y. That'd be an easy way to do that, right? Y equals 3x. And it would be plus 0 if you need it. That means we're going to start at 0, 0, the origin. 1, 2, 3, 1. 1, 2, 3, 1. Alright, so I got my first line already. Alright, here we go. Let's use the green. We haven't used that yet. And subtract 2x and subtract 2x. So y equals negative 2x plus 5. So hello 5. We're going to go down 1, 2, and over. Oh, that's too easy. So the first thing I have is point of intersection. Next thing I'm going to do is put the line on there. It's too easy for you guys. I have to find something to challenge you here. Alright, so we have 1, 3 as the ordered pair. And what we can always do is plug this back in. If I plug in 1 for x and 3 for y, I will get 0. And 1 for x and 3 for y, I will get 5. Can always do a simple check by checking it out that way. Alright, again, I'm not trying to confuse you, just trying to show you this is how some problems may be presented. So these are my slopes over here, and these are my y-intercepts. So y-intercept of 8, because it's already y equals, so that's good. And it's going to go down and down and down and down. So I know it's actually going to meet up with 8 over here if we go 1 and 1 each time. So that's a quick way when I'm given a negative 1 slope to get those. That looks good. Second problem, I've got 4. And this one's going to go down 1 and over 3. Down 1 and over 3. 1, 2, 3. Down 1 and over 3. So I found my point of intersection already. I'm going to put my line on there to line them up. I tell you, I'm getting pretty good at this. I'm getting pretty good. Alright. So we would be very happy to see an answer right there. And let's use... So we're looking at 6 for the x value, and it looks like we went up 2 on the y-axis. 6, 2. Alright. Now we have some things to remember. We have y equals negative 3. Well, y equals negative 3. Well, that's right here. And right here. And right here. And right here. So we're talking about the horizontal line. That runs right through there. So make sure to remember that one. The second line, hello there second line, minus 4x, minus 4x. Y equals negative 4x plus 1, so plus 1. Down 1, 2, 3, 1, I lost track. 1, 2, 3, 4, and over 1. So we find the point of intersection before we do anything else. And if we get an ordered pair, it looks like 1 combined with, I know it has to be negative 3 on the y because that's the only thing it can be based on this equation. So I knew before I get started the y value has to be negative 3 because that's the only thing y is in the first equation. Alright, so just to give you some vocabulary, graphs of systems of linear equations may be intersecting lines, parallel lines, or the same line. That sounds familiar. We just talked about that in the very beginning. A system of equations is consistent if it has at least one solution, and inconsistent if it has no solutions. Okay, think about that. So if it has an answer, it's consistent. If it has no answer and no solutions, it's inconsistent. If it is consistent, remember that means it has at least one solution. It can be independent if it has exactly one, or dependent if it has an infinite number of solutions. Okay, we'll tie this back to our first page of notes back in class.